Hi Sienna, I have question 4 updated here for you. I realize what they're asking us to do is to substitute in any value, which they've signified with A, and then they're going to let A approach 4 at the very end to see what the equation of the tangent line is for the instantaneous. And so over here, if I substitute A into the equation, that's what I get, 10A squared plus 100. And if I substitute 4 into the equation, this is what I get, 260. So I'm going to take 260 minus 10a squared plus 100. And then when I work that down, I end up with the limit as a approaches 4 of 160 minus 10a squared over 4a. If I do some factoring here, I could take a 10 out. And what would I have left would be 16 minus a squared. And I have 4 minus a on the bottom. So if I factor further, if I factor this as a difference of squares, it's 4 minus a times 4 plus a. And that's exactly what we're looking for because we have 4 minus a on the bottom as well. So those can cross out and do slashy slashy. So if I want to substitute in a equals 4 now, I'm not going to get a 0 in the denominator like I would a minute ago where I would have had 4 minus 4 equals 0 down here. So substituting in a equals 4, I'll just put therefore m equals 10 times 4 plus 4, and that's $80 per year in terms of the rate of growth. That's the instantaneous rate of growth right in the 4th year. Okay, for question 1 here on the second set of practice problems, if you're starting out with f of t equals 20 minus 450t squared, then if we want the first derivative, we have to set that up as lim as h approaches 0, and we're going to take t plus h, and put that into the function. So we'll have 20, but it's going to be minus 450. I guess I'm writing too high up on the screen. 450 times t plus h squared. T plus h. Okay. Then we're going to just minus the original formula, which was 20 minus 450 t squared. And I'll put that in brackets. Okay. And then on the bottom, we always just have h. And so that's what we have here. So this is our first derivative. And what we need to do is play with it algebraically and try to reduce it so that we can factor out a factor of h, and then we can let h become 0. Because right now, if h is 0, we get a denominator of 0, and that's undefined. So if I'm going to go down one more line here, I'll go equals lim as h approaches 0 of 20 minus 450, and then expanding the binomial t plus h squared is going to be t squared plus 2t plus h squared. Then I'm going to get rid of the bracket in the second half, and I'm going to go minus 20 plus 450 t squared. And that's still all over h. Next line, I'm going to further simplify the numerator. 20 minus 20 is 0. And I'm going to have minus 450 t squared minus 900t minus 450h squared plus 450t squared, sorry. Okay, so that's going to get, this middle term here should have been th, not t. 2th, squeeze that in there. So that makes this one 450, 900th, okay? So minus 450t squared plus 450t squared, those are gone. I'm still all over h. the last step is to always factor out that h term. So in the top, I have an h in both terms, and so I would be left with minus 900t, and then minus 450h all over h, and the h's cross out. So now if I let h become 0, I just get minus 900t, and that's the first derivative, okay? So this is going to get easier when we do our second derivative because we only have negative 900t as our function, and so it's going to be a lot easier substituting this into our second derivative. So let me change colors. I'm just going to move some stuff off to the side a little bit here so that we have a fresh spot to work. Okay, so now if f prime of x is negative 900t, and I want to find the derivative of that, which is my second derivative, then I'm going to have f of t plus x, so it's going to be lim again as h approaches 0, and I'm going to have minus 900, and instead of t, it's going to be t plus h. I'm going to minus the 900, negative 900t. I'm going to put that over h, and I'm going to work this down just like the first one. And so here I'm going to get negative 900t minus 900h plus 900t. And you notice how anything that doesn't have a t in it ends up crossing out, and that has to happen. So now our h's can cross out, and we just end up with minus 900 for our second derivative, okay? So this is f double prime of x. So going back to the question now, there was another question after you found the derivative, and it was asking what do they mean, and how can we determine how heavy the anvil is from this? And so our first derivative is our velocity of our anvil, how fast it's changing over time. So it's dropping 900 meters per second. Okay, so it's dropping negative 900 meters per second is the speed at which it's falling. The second derivative is going to be our acceleration, and the acceleration is negative 900 meters per second squared, I believe. So if we're looking for how heavy it is, I think what we need to do is take the negative 900 and divide that by the negative 9.8, and that should tell us the number of kilograms, which will be close to 90 kilograms for the weight of the anvil. I really like question 2 because it's a thinking question. You're applying what you already know. So instead of him just giving you a function and asking you to find the first and second derivatives, he's asking you to kind of work it backwards a little bit, like he's just giving you the graph of it, and he's making you show that you understand what the first and second derivatives are in relation to the graph of the function. So what we're looking at for first derivative, remember, is slope, right? So first derivative equals slope. So what we want to know from looking at the graph is how is the slope behaving in this graph. And so one of the things that I noticed right away is there's kind of an anomaly in this graph right here where the slope seems to be horizontal, whereas it's just equal to 0. So slope equals 0 right at the origin here. So something else that we can observe is that on the left-hand side of the graph, down here in quadrant 3, we have our slopes. If we were to draw tangent lines at any point on this curve as it's moving towards the origin, all those slopes are uphill or positive, right? So the slopes are all positive. That's my short form for positive. And they are decreasing because we're almost at like an infinite slope here, right? And then the slope is going down, down, down until it flattens out at 0. And after it passes through 0, we try to do that again, and look what happens. We still have positive slopes, only this time those slopes are also increasing, right? So they start off low and they're going sharper, like steeper and steeper. And so if we look at our first derivative and we are being asked to graph it, they want us to sketch it, then we've got our x and our y here. And if this is the graph of the first derivative, or the slope, okay, then what's the slope doing? It's positive, but it's decreasing in value. And so it's positive, but it's coming down, 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 down until it hits 0. After it hits 0, it turns around, and then it's positive again, so it's up, 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 up. So it looks like our slope of this function is going to be a second degree or quadratic function in the shape of a parabola, and it's going to look something like this. Okay? So now if we consider what happens when we're doing the second derivative, the second derivative is the derivative of the first derivative, right? So the slope of the slope, in other words. And so what we're looking at here is that all of the tangent lines here, 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 and so on are decreasing until they get to 0, and then they're increasing. So this is different, right? So our slopes are decreasing, going down. So first we have a negative slope on this side, and then on the right-hand side we have a positive slope. And we're going to show that on the graph. If we've got a quadratic function for our first derivative, that's the exponent 2, then our second derivative is going to be linear because the derivative of x squared is just x, or 2x, right? And we know that all the values for the slope before we get to 0 are negative, so we would come up in a straight line like this, and then after that the slopes all turn positive, so we're going to carry on through that line and just continue on with our straight line representing our second derivative. Okay? That's a good question. Let's have a look at this last one. This is another great thinking question. I like these questions. Okay, so P is the number of a particular product that a company is producing. M is the amount of raw materials that they need to make it. And R is how much money they're going to make when they sell it. So let's think about what DM DP means. And again, he's really testing your knowledge, like your understanding of what these concepts are, which I really like. Okay, so DMDP, that means the change in materials, okay, that we have available. And then DP is the change in production. Okay? So what do we think will happen if the change in materials, if it starts to decrease, if we start to deplete our materials without reordering them or replacing them, then what's going to happen to our production? Our production is also going to be affected because we can't produce anything if we don't have the raw materials, right? And so it says the remaining raw materials. Okay, so this should be a negative over a negative, right? So as one thing changes, the other one changes. As one thing goes down, the other one goes down. And so we'd be looking at a negative. I think we'd be looking at a negative value here corresponding to a negative value here. Like the more that the supplies go down, the less we're able to produce. So overall, a negative over a negative would give us a positive, wouldn't it? And then if we were looking at DRDP, and DR is revenue, and P is the amount you produce, then again, DRDP, I'm going to make more revenue if I produce more goods. If I can't produce more goods, if I decrease my production, I'm going to make less revenue, usually, right? Like you could flood the market and not make the revenue that you were making, but that's kind of more of a business side of thinking, so I'm not sure that he wants you to get into that. I would think that DRDP, if one goes up, the other goes up. If one goes down, the other one goes down. It's going to be also a positive ratio or relationship. And so I think that both of them will be positive. And I think we've explained why in terms of reasoning this out. And you would have to put that into a couple of 2 or 3 sentences for each one.